Excellent. Okay, so the recording has started and we are off. All right, ladies and gentlemen, welcome to Extending DevOps Practices to SQL Server Databases. Um, hopefully you're in the right place. You've been hanging out here for a little while, a bunch of you, so we're going to get going. My name is Grant Fritchey. I work for Redgate Software, and this is my contact information. If you want to get in touch with me after today, talk about DevOps, talk about deploying databases, talk about Redgate in general, query tuning, any of that fun stuff. I will love to talk to you. I will answer my email. You can get in touch with me, and I will do my best to answer your questions or help you out in whatever way I can. So that's my contact info, and this is Arneh.
Thanks. Hi, my name is Arneh Eskandari, and I work on the sales engineering side here at Redgate. I've been with the company for 6 years, and as part of my role, I work with a lot of our customers, looking at their existing end-to-end database change management processes and making recommendation on best practices around how to move towards the DevOps practices. As well as helping customers get up and running with the Redgate solution. So here are my contact details. If you have any questions after the webinar, then feel free to reach out.
Great. All right. So what we're going to go through is we are going to talk about Redgate, and then we're going to start talking about DevOps and how DevOps is impacted by basically all kinds of fun stuff and how it impacts databases, database deployments, database management, and how getting this under control and getting a methodology around how you deploy databases is absolutely going to help you integrate better with both your development teams, development processes, but also your businesses and business processes. It's all going to be better if you set up these kinds of methodologies. And then we're going to talk about how Redgate can help you do that. And then we get some pretty cool demos to run through for you. So that's the agenda. Hopefully you guys are sticking around for it. So Redgate Software, 600,000 technology professionals around the world. We've got a lot of the top companies and
I think we lost your audio, Grant.
I know my audio just went out. I think it should be good again.
Yeah, we can hear you.
Yeah. Okay, cool. So, by the way, I'm broadcasting from a hotel room in Bellevue, Washington. So if things get spotty, I've got a Wi-Fi backup, so we'll get going on that too. So we've got a poll open, I believe. Just curious who has used any kind of Redgate software tools. So if you can fill that out, and then we'll report on the results. The thing is, we're pretty dedicated to community and pretty dedicated to making good tools for you guys. So we use SimpleTalk and SQL Server Central as our means of communication and a way for you guys to share with each other. SimpleTalk's got 400,000 subscribers. SQL Server Central is the largest data platform community on the planet at 1.4 million. So if you're not taking part over there, please start. That's a great place to get a lot of good information.
All right, so it looks like about 70% voted, so I'm going to go ahead and stop that. And as always, looks like there's a lot of compare users.
Right. Not a shock.
Yeah.
Cool. All right, ready to keep going? Awesome. So the thing is, DevOps is hard. DevOps is useful. DevOps is vital. But DevOps is not easy, especially when it comes to databases. The very core of DevOps, the basic principles, is a method of communication between development and operations to ensure that you're moving things in a faster, efficient way. You're getting out the door quicker, but you're also getting out the door better. The whole idea of DevOps, the concept of shift left, is to ensure that you're getting higher quality software. The problem is that databases, I don't want to say get in the way, because they don't, but they can slow things down. They can affect the methodology. And it's because of the fact that databases maintain state. They persist that information. They stick around. And you need to have processes and methodologies around your deployment to ensure that that data sticks around. I mean, after all, it would be so simple, so very simple, to simply drop the database and deploy a new one. It would make things quick. It would make things easy. You would never, ever, ever fail in a deployment that way. However, businesses get a little picky about maintaining their data, and so you can't simply do that. You have to build methodologies to support software rollouts while still protecting that database. Come on, move to the next slide. You're giving me a hard time for. There we go. So what happens when you're not maintaining these kinds of processes, when you're not spending the time to coordinate your deployments between development and all these other things? I mean, one of the main things that's going to happen is you'll see a lot of things where the databases are out of sync. The application development will think that they're deploying the latest set of database code, while meanwhile you'll have made other changes to your production system, and these things will no longer be the same. And so you won't be deploying accurately, and deployments could fail, could break things, could cause data loss. Another issue that you're going to run into is that people are not using methodologies and processes that ensure a traceability of the database changes. And it's not simply running a change log, because I mean, I know as a DBA that at 3 a.m. I'm not necessarily great at filling out that change log. I may be really good at it. I may try hard, but I still can screw up. So you need processes in place that ensure that changes that you make are tracked really accurately. Otherwise, you don't know what things are. Also, the ability to roll back to a previous version of the database is pretty hard, very hard, because it involves, again, data persistence, new data being introduced. But even if you're not sweating the data, just getting your databases back to previous versions is a serious challenge if you don't have a process in place to know where you're deploying from and where you're deploying to and what you are actually deploying. Also, because of that data persistence, because we can literally come to a stop when it comes to deployments, databases become a bottleneck in making an agile, fast-moving process, mainly because of that data persistence again. It's the one that comes back over and over again. You're not going to get away from it. You must protect production data. You have to. Regardless of whatever process you want to set up, you still have to protect your production database. Also, if you're moving slowly, if you're not in an agile process, then you are moving your releases out the door less frequently. And that means probably each release is bigger. And so bigger releases are more problematic releases. The bigger and the larger the number of changes you're putting out the door, the higher the likelihood is that something could go wrong. And so you're in a more risky environment by moving fewer releases out the door. It feels safer because it's like, oh, well, change is bad. But the fact is that change is constant. You're only ever going to see change. So the best thing to do is develop a process so change. Now, this can't be manual. I know DBAs all over the world. I've talked to them. Oops, what happened? No, okay. I know DBAs all over the world. I've talked to them, and they insist that they read all 10,000 lines of that change script that's coming out the door. And let's be honest, everybody, you don't, right? You don't read all 10,000 lines. I mean, okay, maybe there's a few of you do, or there's 2 or 3 of you who honestly read all 10,000 lines of that change script, but most of us do not. We look at the first few lines, we glance through, we maybe do a search for any kind of some kind of phrases or common methods that we know that are somewhat problematic, and then other than that, we will try to run the script once someplace prior to production. That is a manual process that is going to be slow, it is going to be inaccurate, and it's just going to lead to problems. We have to be able to go into a CI or CD process. Continuous integration and continuous deployment are mechanisms that application developers have been working on for years to ensure accuracy in their code. We need to do the same thing with databases. And then, frankly, the deployments, as constructed, especially when they're manual, require hours and hours and hours of time. And so the whole idea is to try to start to eliminate this stuff, to move away from these bad effects. So what do? We start looking at lifecycle management, and we start looking at DevOps. Because what we want is we want to arrive at a place where we've got predictable, repeatable processes, where they're automated, where we're eliminating not the people, but the people's manual activities, right? You're still going to be building these processes. You're going to be maintaining these processes. You're going to be working within these processes. So we're not talking about eliminating a DBA. In fact, the amount of work you're going to have is going to go up. You're going to have more work, not less. However, that work is going to be around automation, and it's going to be around building and maintaining process that arrives at a safe delivery of change, because you want to go faster. We have to go faster. The way the world is changing, the way technology is shifting, it's not slowing down, people. It's speeding up. So we have to be able to have databases go with it. Otherwise, you do get people trying to bypass the DBA team with NoSQL style storage, because semi-structured or unstructured data storage is ridiculously easy because you just do whatever. Funny thing is, it's actually really kind of hard to report against. There's all kinds of other issues. You will find yourself doing data cleansing more, all kinds of other fun stuff. But it's all because the DBA team has a tendency to say no. And if we can get DBAs hooked into database lifecycle management, we can get DBAs on board with DevOps, then we can get to a place where we're getting faster processes automated, and we've shifted left, meaning we've moved deployment away from production as a first-time thing down to staging, down to QA, down to pre-prod, down to some kind of continuous integration process that checks everything coming out of dev. All of these ensure that we're deploying earlier and more often, and that helps us to get to a more stable, safer deployment process. This is all about safety. This is literally the DBA's wheelhouse. This is something you guys should be focused on as data professionals, as DBAs. You should be wanting these kinds of integrations because it will protect your production systems better, not worse. So there was a report, the 2016 State of DevOps, and they do find that there is a very high correlation between practices such as continuous delivery, such as version control, and high-performing IT organizations. It's basically the more agile you are, and the more repeatable you are, and the safer you are, and the fact that if you're able to move quickly, safely, you are one of the higher performing IT organizations. And if you want to be one of the higher performing IT organizations, just like anything else in life, if you see somebody who's doing great stuff and you'd like to be that person, what do? You emulate them, right? That's just how it kind of works. And so you see organizations doing great stuff. What do? You emulate them. So firms with high-performing IT organizations are twice as likely to get better profitability, better market share, and better productivity goals. In short, doing this kind of thing helps the business, not simply helping IT, not simply helping you, your job, and your career, although, by the way, it helps every one of those things too, but you're helping the business. So all that sounds great, right? Now, is it easy? No. Like I said earlier, you're going to be doing more work, not less. You're going to work harder, not less. You're definitely going to need to do more stuff. However, I think we can pitch in and help out. So the whole idea here is that you're going through operations. This is all about protecting production, absolutely. And you've got development. So Redgate hooks in across the board. What we've got are tools designed to help you with development. SQL prompt, SQL source control, SQL test, and frankly, SQL compare. All of you guys are a healthy percentage of you are already using it. We've got our tools in development plugged directly into Visual Studio, and we work with SQL Server Management Studio, of course. Now, from your basic development, works on my laptop kind of thing, you want to move into continuous integration where you have a continuous testing environment going on to ensure that as changes are done, they get deployed at least once, and they get tested. Now, that's where our DLM automation tools come in, and they work with you across all of your environments, testing, QA, staging, pre-prod, however you've got it, to ensure that you've got a release management process, and they hook, again, into the same tools that you're used to using. Visual Studio Team Foundation, Visual Studio Release Management, and all the really cool tools like Jenkins, Bamboo, Octopus Deploy. These are fun tools. I really do like them. But our DLM automation suite is, frankly, built around PowerShell and therefore automatable. So that can help you with all those processes. And then finally, when you arrive at production, you've got to do backup, you've got to do monitoring, and you've got to maintain, and keep track of changes that are going on. Again, we've got a set of tools there to work with you: SQL Monitor, SQL Backup, and DLM Dashboard. Now but we're going to start with development, mainly because that's pretty much where everything starts, right? You got to build this stuff before you deploy it. And we're going to start off with source control, and we're going to talk through source control. The key thing of source control is you can use Visual Studio Team Foundation services. You can use Vault, Perforce, Mercurial. We support all of them, but all the cool kids are using Git these days. And so we're going to walk you through how to do development, how to do source control, how to do branching and all kinds of other fun stuff using Git, along with your database code, and your other people. So the whole idea here is you want to create tables, you want to create procedures, you want to generate change, right? All that stuff you either you could even use Entity Framework and Hibernate and generate these scripts, or you may be writing these scripts by hand. Either way, everything goes in and out of source control. You start there. If it's not in source control, it does not exist. That has to become a mantra by which you live. Once you're there, once you've got it in source control acts as a trigger to fire off the continuous integration process. So that then will do a build, do a deployment, do validations, ensure that it works for you. And then from there, you create, I always call it an artifact, but what do I mean? I mean a T-SQL script. You create a T-SQL script that can run on testing, QA, staging, and prod, and that same script gets tested over and over again through automated processes, again, something like Octopus Deploy or whatever, excuse me, to arrive at automation so that you get to production with a safe, tested script that has been run over and over again, not simply one time just prior to production. And after having gone through that 10,000 line read that we all already know that we don't really do. So if you want to validate this stuff, you validate it through an automated process. Come on. So ultimately it generates a script, as I said, and it does the things that you want it to do: alter table, create proc, or drop index as needed. All right, I'm going to turn it over to Arneh, and he's going to start running you through all the fun toys.
Awesome. Thank you so much, Grant.
Sure. Oh, and by the way, if you guys have questions, there is a questions window. I don't think we mentioned it earlier, but please type into there, and we will try to help you out.
Okay, excellent. So let me go ahead and make myself the presenter here.
Oh, yeah, sorry, I should have switched. My bad.
No problem. All right, so let's make sure you can see my screen okay.
I can see it.
So, okay, fantastic. So for the rest of this session, we're going to show you how Redgate can help. So I'm going to walk you through the process that Grant just described as part of the diagram using Redgate SQL Tool Belt. So, so again, we'll show you how Redgate tools can help your DevOps process. So again, we're going to help you with your DevOps process. It's not about, these tools are not going to help you create a DevOps process. So as Grant mentioned, DevOps is all about collaboration and communication between developers and operations with the shared goal of delivering quality product out to the end users. So these tools will help you, solidify that process, but it all starts, from processes, and then you look into tools to help with that. So, so for today's demo, we're going to be, we'll show you how you can source control your database changes. So obviously, source control is always the principle, the main fundamental piece. So if your changes are not in source control, then you're not even ready to do DevOps. So so we'll show you how easy it is to source control your database changes through Redgate SQL source control. And from there, once our changes are in source control, which is Git for today's demo, then we'll look into how you can automate your builds and do continuous deployments to your higher environments through our SQL tool belt. So, so we'll start off with our development environment. So the database that I'll be working with is this AdventureWorks 2012 Git database. So this represents my development environment that we'll be making changes to. I also have a couple of other databases here that represent the higher environments that we'll be deploying to. So I have UAT, staging, and production, which are the databases that we'll be doing deployments to later on today. So starting with our development environment, so you'd notice that my database icon is green. This is an indicator of the database being linked to source control already. So again, I'm using Git as my source control system. So obviously the workflow with Git is that you check in your changes locally into your working folder on your local disk, and from there you push to your remote repository. So for today, I'm using GitHub as my remote repository. So this is what my source control folder or repository currently looks like. So when you link your database to source control through our SQL source control plugin, we go ahead and create this folder structure for you. So as you can see, there is a subfolder for each type of object. And within each of these folders, we store the create scripts of the object. So we carry the state of the database in source control. And when it comes to doing deployment, we rely on our compare engine inside DLM automation to generate the update script by comparing what's in source control against our higher environment. Now, one common question that I get a lot from different customers is, how do you group specific database changes that are associated with a specific feature or a project or a team of developers or even a specific application, and when you're deploying, only make sure that those changes are the ones that you want to deploy. So so to show that, we'll be looking at branching strategies in Git. So I'll show you how you can utilize branches in your source control repository to basically create those groups of changes. In this case, it'll be feature-based. So we have a branch. So if I go to my branches, you can see I have a master branch, which contains everything. And I also have this feature branch called the new feature A that we'll be working against. So the workflow is that we'll be making our changes, committing our changes into the feature branch. Once our changes are ready to go, then we'll do a pull request in Git to merge those into master, and from there we'll be promoting the changes up to our higher environments as long as the build is successful. So should we go ahead and do a quick poll, Grant, to see what source control system our audience are mostly familiar with or are currently using?
Yeah, I just launched it.
Okay, fantastic.
And sorry, I had my mic open and everyone was listening to me type for a little while there. I've turned it off, and I will make sure I mute it again.
No problem. Thanks.
Okay. We're at around, that's going up still, 82%. Okay, seems to have paused. That's good. And let me share the results here for a second. So you can see that it's 51% Git and 47% Team Foundation Server. And I'll bet even those 47% who are using Team Foundation Server are probably using Git as well.
Probably, yeah, that's what I was going to say as well.
And then
so, perfect.
Subversion and other. Okay, I'm going to hide this, and you can keep going. I'll mute again.
Perfect. Thank you, Grant. All right. So my database is, again, to go with the Git workflow, we will be committing our changes locally. So my database is linked to my local repository. So if I go to my Setup tab, this is the repository that is sitting on my local machine that we're going to commit to. And if I go to my commit tab, here at the top right corner, you can see it's showing the current branch that I'm on in Git, just to make sure that you are on the right branch and you're committing into the right branch. So we're going to be committing into the new feature A branch, and once our changes are ready to go, then we'll do a pull request and merge into master, and that will trigger a build in our CI environment. So we'll be using TeamCity for our build process, and we'll be using Octopus Deploy as a release management tool to handle our deployments going to our hiring environment. So as you can see, there is nothing to commit to source control. It's always a good idea to make sure that you're on the latest version of changes from your repository. So what you can do is you can go to the get latest and pull from the remote repository just to make sure that, so for instance, if you're working on your dedicated database, each developer has their own dedicated database, then you would be relying on this feature here to grab the changes that are in your source control repository that have been committed by other developers and bring them down to your local database. But if you're on a shared development database, then this will not apply to those scenarios. All right, so we're on the latest version. Go to the commit tab. There is currently nothing to commit. So let's go ahead and start making some changes. So I'm going to go to my database, start off by modifying some objects here. So let's go ahead and modify a couple of store procedures to begin with. So need to add a couple of columns to this select statement here. So I'm just going to use our SQL prompt tool, which is our IntelliSense and auto-completion tool for SSMS and Visual Studio. So let's go ahead and select the columns that we want to add to the statement. And I'm going to format it as well to make it easier to read using prompt again and apply my change. As you start making changes to your database objects, SQL Source Control will show these blue spheres next to your objects in Object Explorer to show what objects are now different from your repository and that you need to commit those changes to source control. So I'm going to make another change real quick and commit these changes together into source control. So it's really important to make sure that you're committing changes regularly and you're validating those changes regularly as part of your build process. So in order to make sure, DevOps is all about delivering quality software out to your end users, and fast. And in order to be able to do that, you need to make sure that you are testing your changes, validating your changes as frequently as possible. So the smaller units of changes that you commit to source control and validate, the less risk will be involved when it comes to deploying those changes, because you're only testing small units of changes at the time. And if something breaks or if there's a bug, then it will be easier to fix that as opposed to committing 100 changes together at once. And if there is a bug or bugs, then it will be more difficult to troubleshoot that. So there is always more risk involved if you're shipping a large number of changes together as part of any release going to your hiring environment. So, I'm going to make another change here to this store procedure. made a couple of changes here. So let's go ahead and commit this into our feature branch. So I'm going to go ahead and commit changes to source control. So here you can see it's showing me the objects that are now different from my repository. So those of you who have used compare or are using compare, then you'll be familiar with this comparison report at the bottom here. So as I select, click on each object, it will show me what's different between my development database on that specific object and what's already in source control. So I can see exactly what is going to be updated. So again, we store the create scripts of the objects in source control. So when I do this commit, it is going to update the create script of the store procedure in source control to reflect the latest changes. So that way we can keep track of how specific individual objects have changed over time. And then using compare, we can generate the actual deployment script by comparing against our higher environments from source control. So I'm going to go ahead and write my check-in comment here. So since it's a demo, I'll just keep my comment short. So modified a couple of store procedures, and go ahead and commit. Now let's go ahead and make some more changes, so that way we have a couple of commits that we can then later on merge into our master branch. So on top of schema changes, so actually before we continue, here you can see it's giving me the option to push my changes to my remote repository or GitHub in this case. So everything's nicely integrated into the UI, so you can just do, your Git operations from within SQL Source Control. So before I push, I'm just going to go ahead and make another change. So now on top of schema changes, you can also source control data changes that you make to your lookup tables or your reference tables. So if I right-click on my database and go to other SQL Source Control tasks and link or unlink static data, this will give me a list of tables that I have on my database. And here, as you can see, I have two tables that I'm source controlling in terms of data, so address type and contact type. So when you get up and running with SQL Source Control for this first time, by default, it will only source control the schema of your database or the object. But if you want to source control data, then you would have to go to this window and select the tables that you want to source control in terms of data on top of the schema. So I'm going to go ahead and make a change to one of these tables. So let's say we want to modify the contact type table in terms of data. So let's go ahead and let's see what data we have in that table. Okay, so let's say that we want to delete the last record here since that contact type no longer exists. So let's do a delete. Two 2052. All right, so we deleted a record from this table. And I'm also going to make a table change, so I'm going to add a column to one of my tables as well. So let's go ahead and add a column to this errors table. So I'm going to add a new column called frequency for error and make that an integer. All right, so made a couple more changes. So I'm going to go ahead and commit this to source control as well. All right, so again, here's the report of what's different. So on the data side, as you can see here at the bottom, we store data as insert scripts. So inside our source control repository, there is a data folder. And within this data folder, we store a .SQL file for each table that you source control in terms of data. And then within these files, we store the insert scripts for all the records that exist within that table. So, so here you can see this is the difference as far as the data is concerned for the contact type table. So there is that record that we're deleting, and it's going to do that. There is no other differences in terms of the other records that exist on that table. And for the errors table, we just added a new column. So I'm going to go ahead and select those and commit them to source control. So deleted data from contact type and added a new column to errors table. All right, go ahead and commit that to source control. And now I can go ahead and push these from my local repository to the same branch in GitHub. So let's go ahead and do a push. So now there are 2 commits that we're going to be pushing. So I'm going to go ahead and push these changes over. Okay, so now they're pushed. Now let's take a look at GitHub and see what we have here. Okay, so if you look at our feature branch here, okay, so you can see it says this branch is now 2 commits ahead and 2 commits behind master. So what I can do from here is I can create a pull request to go ahead and get these changes merged into our master branch, which will then trigger a build in my CI environment. So as part of the pull request, you can either have someone review the changes, whether that's a senior developer or someone from the team or a couple of people from the team who can review changes, or you can, if there's no one to review, then you can just go ahead and do the pull request without anyone else reviewing the changes. So I'm going to go ahead and do a pull request to go from the feature branch to the master. So here at the bottom, you can see what commits are included in this pull request. So we modified this to procedures, and we deleted data. So here at the bottom, you can see exactly what do the merge as well. So just going to add a comment here, and I'm going to go ahead and do the merge. Okay, so now we merge the changes into our master branch. So the master branch represents what is ready to go. So our feature is ready to go. So we basically just went ahead and merge into master. So in return, it will trigger a build in our CI environment. So here, if I bring TeamCity over, we have, this is our build project. So as part of our DLM automation, you have 2 options as far as configuring your build steps for your database. You can either use our plugin, which is a wrapper around the PowerShell commandlets that we offer as part of our DLM automation, or you can just use PowerShell scripts and use our PowerShell commandlets if you want to have something that is more customizable as far as the build steps are concerned. So this is the project that we are running. So while we're waiting for the build to get triggered, I'll quickly walk you through my build steps so you can see there's now some changes pending that are going to get built. And here's you can see the build got started. So while that's running, let's take a look at our build steps for this project. Okay, so here I'm using our plugins for TeamCity. So we offer different types of plugins for different source control build systems. So there are extensions for TFS, for example, that you can utilize to achieve the same process, or Jenkins, or Bamboo, or TeamCity, as you can see here. Or you can just stick to the PowerShell, as I mentioned earlier. So our first step is the build step. And what the build step does is that it tries to create the schema of your database from scratch on a temporary database. And that also includes any lookup data that you put in source control. The reason why we're trying to create a database schema from scratch is to make sure that your database, there are no broken dependencies and any SQL Server compilation or syntax error. So it's just to make sure that we're going with the principles of CI. So on the application code side, you need to make sure that your application code or your solution can be compiled from scratch. So on the database side, since there is no compiling, then basically the similar process to that would be to recreate a database schema on an empty database, and that's what we're doing here as part of the build process. If that temporary database build succeeds, then we go ahead and package up your database files from source control into a NuGet package, which is just like a zip file, but it accepts some metadata such as version number and ID on the file. So once that NuGet package is created, then it becomes the lockdown version of what you've already validated and tested from source control, and you can use that NuGet package as your source of deployment going to your higher environment. The reason why it's a good idea to always look, use a lockdown use a package as your source of deployment is because source control can change anytime, right? So someone could go ahead and merge a change into master. So comparing directly from source control to your higher environment may not be a good idea in those cases. So for that reason, we package up the database into a NuGet package to make sure that you cannot modify it and make sure that you're going from the same state to all of your higher environments all the way to.
Hey, Arneh.
Hey.
I'm going to interrupt you for one question because I think it's an interesting question. I want to. I've been answering most of them online, but this one I think we should bring it out. So if a developer is working, Nathan Clark asks if a developer is working on feature A and another dev is working on feature B, and both need to update the same stored procs and tables. Which, by the way, why would two features be using the exact same store proc? Anyway. Seems like there could be merge conflicts. How do you manage the conflicts?
Yeah, you're absolutely correct. So depending on which feature gets merged into master, then when, let's say, feature A gets merged into master and then feature B goes to get merged, then it will show a conflict on the merge on that specific store procedure. So you would be relying on what's available as part of Git to resolve the conflict. So you could use a tool like source tree or a Git client tool or any other tools that you might already be using on the application code side to handle those merge conflicts. But Grant brought up a good point. If the same object is being used for two different features, then that could be problematic. Like, for instance, if you've made some changes to the same object, but the changes from that object aren't ready to go, but you also have some other changes from that object that are actually ready to go, then that causes some conflict, and you might end up pushing out a version of the object that may not work with the current feature that you're trying to release. So I've seen customers maintaining different copies of the same object under different names by putting some version numbers at the end, and then to specify which feature those objects are associated with, although it's the same object. So it can become problematic. So hopefully you don't have a lot of objects that conflict from one feature to another, but if that does happen, then that would the merge conflict would need to be resolved using a Git client tool. So yeah, so you can see here I can even pull this, and it's using source tree. I can pull down the master, so it will show me what has been merged into the master branch. So it kind of gives me a nice visual of my branching strategy. So here you can see we made those two changes or those two commits, which included 4 changes in total. We merged those into the master branch and created pull requests. So so go back to TeamCity. If you take a look at our project, you can see our build was successful a couple of minutes ago. So what we did as part of the build process, we ran that build, created a NuGet package. We also ran some tests. You can see here it shows there was 34 tests that passed. So we rely on the T-SQL-T framework and the SQL comp testing framework to give you the ability to run some automated tests on your database as part of the build process. So if you look and take a look at the tests, here are some of the tests that I'm running. So I'm running a bunch of tests from SQL comp. SQL comp is a code analysis testing framework, just like .NET COP. So just to make sure that you're following best practices as far as naming objects or scripting objects and creating tables and so on and so forth. So the good thing about SQL COP is a lot of these tests come out of box, right? So you can just go ahead and get them installed. They come as stored procedures, so which means that you can easily go in and modify and customize those tests if you want to. So if I go to my stored procedures, you can see I've got a bunch of objects starting with the SQL COP schema. Here, these are the out-of-box tests that are available to you. And if you want, you can go in and modify any of these stored procedures. So it's all pure SQL as far as the script that is running in the background. So, so all of my tests were successful, and as a result of that, we went ahead and sent the NuGet package to our NuGet repository that is being used by Octopus Deploy, which is the release management tool that we're going to look at. So, so I guess before we do that, let's go ahead and run another poll to see what build systems most of you guys are already using or familiar with, and then we'll move on to looking at what the deployments would look like going from source control to our higher environments.
Right. Just started it, and we'll it's coming in right now. People are voting. Pretty active. You're not going to be real shocked by the report. Well, the fact that people are using none in such large numbers is creeping me out. Okay, looks like it's paused. We'll close it now and share the results. So you can see it's mostly TFS Team Build and TeamCity, which, I mean, not shocking, and a bunch of people on Jenkins and a few people on other, but 30% on none. Oh, so creepy. All right, so I'll hide this.
So hopefully that's the reason why they're on this webinar. So, yeah, so TFS, no surprise. I think with the recent releases of TFS 2015 and 2017, a lot of people have started moving towards TFS because of that nicely integrated environment where you can do your source control, your builds, and releases all from within the same environment. One of the audience mentioned that they're using TFS release management tool now, and I'm assuming that's the release management that came as part of TFS 2012 and 2013, which does the job, but it's very difficult to work with and configure. So I definitely prefer the latest version of TFS, which has made things so much easier as far as setting up this end-to-end process, going from source control all the way to deployments to production. All right, perfect. So, so we built the package, and we went ahead and published the package to our artifact repository for our NuGet packages. So you can see the last step was to publish the package to Octopus Deploy. So again, this is optional. In this case, we're using Octopus Deploy as our release management tool, so it needs to have access to the NuGet package that we'll be deploying from. So, so for those of you who are not familiar with Octopus Deploy, again, it's a release management tool. It makes it really easy for you to define and configure your environment for different types of projects and manage your releases going from one environment to another. So it gives you a nice audit trail of what releases you pushed out to which environment, which releases failed, which releases were successful, and which releases are pending approval or a review process. So the project we'll be working with today is the AdventureWorks Git project. So the first thing I need to do is to create a release. And as you can see here, we are going to create our release based on the latest NuGet package that came from our build process. So if I go back to my build here, you can see that our most recent build was 1.121. So we package our versions based on, we version our packages based on the build number to make it easy for us to tell what build number our packages are associated with. So, so we're going to take the latest package, and we're going to create a new release with this version. So go ahead and save that. Now I can deploy from the package to our higher environment. So I'm going to start off the deployment to our testing environment. Again, you can automate this whole process if you want, all the way to production or even to some of the environments. For instance, we have customers who every time they get a successful build, they automatically go ahead and push out the changes to the testing environment without any human intervention. So you can set that up using the command line of the tool, or you can just do one-click deployments through the user interface of your release management system. So I'm going to go ahead and start the deployment to my testing environment. And while that's running, I'll quickly walk you through my deployment steps that I've configured for this project. So again, we're utilizing our DLM automation component from the SQL tool belt to help us define the deployment steps. So for Octopus Deploy specifically, we provide a set of templates that you can utilize, which is again a wrapper around the PowerShell commandlet. But if you're more comfortable and confident with PowerShell, then you can just use PowerShell instead. So what we're doing for different environments, so as you can see, starting with our testing environment, we're running this deploy from package step. So this step basically runs the comparison between the NuGet package and our testing environment and generates the update script and executes it using the compare engine. But going into staging and production, I've actually broken down that same process into multiple steps. So the first one is creating the database release, as you can see here. What this step does is it generates a report of what is being deployed. So what are the differences going from our NuGet package to the target environment, and what does the update script look like that we need to execute in order to deploy those changes. And then from there, I have a manual intervention step for someone to manually review the deployment artifact or the report. Make sure that all of the changes that are going out are valid and that there is no risky changes or risks of losing data going into the higher environment. If everything looks good, then we can approve the deployment, and it will continue to the last step, which is the execution of the deployment script to our staging or production environment. So let's go back to the overview, and you can see the deployment to testing was successful. So I'm going to go ahead and promote this to staging to show you what that manual intervention and the review process would look like. So this is going to go ahead and start the comparison from our NuGet package to our staging database. And once it's done that, then it will generate a bunch of files here under the artifacts that we'll need to review before we can continue to the execution of the deployment script against our target. So once step number 3 is complete, then it's going to stop the deployment, and it's going to ask us to review the artifacts. So that should go ahead and complete in a couple of seconds here. Right, running everything from my machine, so that's probably the reason why it's a bit slow. But doing this on a proper build system or a system that is dedicated for doing builds and releases, then it will be so much faster. All right, so here you can see our release got created. We've generated that report, so that is this changes.html file that we need to review. So I'm going to go ahead and open up that file to see what kind of changes we are pushing through. So, so this is a report of what objects are being affected and how. So, you know, amber is objects that are being modified, red is objects that are being dropped, green is objects that are being created. So in this case, we mostly just modified existing objects. So here we went ahead and added a new column to the error table. And if we look at the other objects, you can see exactly how the other stored procedures are being modified, as well as data. So if you look at the contact type table, you can see the data that is going to be deleted from this table as well. So, so this is just showing us how what the state of the objects are and how they're going to change. And if you go to the warnings tab, this will tell us if there's any risks of losing data, or you know, if you're dropping tables, columns, rebuilding tables, then you will see warnings under this tab here. And finally, the deployment script. So again, for those of you who are familiar with compare, then there's nothing new here for you guys. So you can see here's the alter table to add the new column, alter procedures, and finally the delete for that record that we deleted from contact type. So everything is nicely encapsulated into a single transaction. So if the deployment fails while executing the script, then it will roll back the transaction to the beginning. So that way it doesn't leave your target environment in an inconsistent state. So everything looks good. So I'm going to go ahead and improve this deployment. And I'm going to assign it to myself. And go ahead and proceed. And now that's going to go ahead and execute the deployment script that we just reviewed against our target environment. The nice thing about this, again, is that it gives you a nice audit trail of exactly what you've deployed in your previous releases. So I can go to my previous releases and take a look at that changes.html file and see exactly what was deployed as part of each release. The nice thing about rolling back changes is that you can point to the comparison to an older release or a NuGet package from an older release and compare that package against the current state of your environment and generate a rollback script from there in case if you need to roll back some of the changes going back to previous versions. So, and you can see our deployment was successful. So the process of going into production would be pretty much the same as what you saw with staging. So since we only have a couple of minutes here, I'd like to stop the demo and see if there's any questions that are outstanding that we need to answer here.
I was just typing one.
Okay.
Hang on, let me just finish that. Be just as easy for me to send that rather than, let's see, TFS releases direct hooks within the Octopus Deploy. Hey, Arneh, what version are we up to on the DLM tools?
What version of TFS you mean?
No, the DLM tools themselves. What's the latest release?
The latest release, I can double check that real quick. So DLM automation, releases, so it should be
2.
I think 2. Yeah, so it should be 2. Yeah.
Okay, because there was a question on that. There was a question on that. They said they were only seeing 1.5, so I thought we'd updated them. I was pretty sure, but I just wanted to validate that.
Yeah, 1.5 actually uses the older engine, so I would highly recommend to update to version 2.
So is DLM automation a plugin for TeamCity, also a plugin for Octopus? Yes, it plugs into both those tools.
Correct.
How does Redgate licensing work out, by environment or by users? I'll leave that one to you.
Yeah, sounds good. So the licensing is per user, and by a definition of user is your development team who will be making changes to your databases and committing to changes, as well as DBAs who are normally involved in the deployment process. So DBAs who used to run the deployments manually, but now this is kind of going to help them. So that's basically the definition of users. So most of our products are licensed by user, except our monitor tool, which is licensed by operating system, as well as the backup tool. But everything else is licensed by user from the SQL tool belt.
So another question just came in. I'm just going to answer them out loud now because it's quicker. Does the developer make direct changes using SSMS in the DevDB, or is testing the dev database? Frankly, that's your environment to set up, your methodologies to approve. We'll work with it either way. Generally, I would suggest going with isolated, although there is very honest disagreement there, isolated versus shared. I would go with isolated so that each dev works on their own database, and then then integration occurs elsewhere. So that's, and source control is by user, DLM by environment. Okay, let me close this one because we've got pretty much everybody who's voted on it. Share it. Let's see. Any suggestion for small team? How to simplify the whole process but keep control in CI/CD? Small teams are easier than big teams. Talk to each other, right? I mean, the whole idea of DevOps is about communication, right? So many people I see were like, well, yeah, I can't talk to my dev team. Well, then you're going to have a heck of a time implementing DevOps all by yourself. It's a cooperation. It's a team effort. It's a joint thing. The tooling, I mean, I love our tools. I love our tools to death. Don't get me wrong. But the point here is that these processes are about processes. The tools help, but the processes are the foundation. You guys have to make the choices to do those. Let's see, how's this going to work with TFS 2017? It's going to work great with TFS 2017. And basically the process will be the same. How would you recommend updating a feature branch from master if needed?
Yeah, so that would basically be the opposite of merging from master to your feature branch. So not sure what the use case there is, but you can basically just go ahead and do a merge from master into a feature branch, just like you do a merge from feature branch into master. But yeah, that would be the process. So it looks like there's a bunch of questions that we'll probably need to get back to. Since we're run out of time, and I know Grant, you got to run to.
Yeah, I need to run.
As well. Yeah. So what we'll do is I'll go ahead and stop the recording